Hello class, welcome to the next lecture on signals and systems. In this lecture we will be dealing with the basic operations on signals. Okay, so suppose we have a signal like this. This is the amplitude variation and this is the time changing. So since this is a signal and the amplitude varies based on what time is changing, right? So basically whatever operations that we are doing on the signal, that can be classified into two. That is, the operations that we are doing to the independent variable, that is t, independent variable, and the operations that we are doing on the dependent variable, that is let's say x of t, right? So what is it? X of t, or the amplitude. Okay, that is why are we calling this the independent variable? Because we are seeing what is happening to the amplitude as t changes, right? This itself, x of t, is a by the nomenclature or definition itself, it is a function of t. That is, the value of this one, this depends on the value of this t. That is why this is called a dependent variable. And as far as we are concerned, we are not modeling t or time as a dependent on anything else for the time being right now. Okay, so we call it a independent variable. So in this lecture we will be dealing with, in this particular segment we will be dealing with the operations that we do on the dependent variable, right? On the dependent variable. Okay, so the first operation is amplitude scaling. Amplitude scaling. Okay, so it is defined as y of t is equal to c into x of t, or y of n is equal to c into x of n. Suppose we have a signal, okay, x of t, right? Let this be the signal. Okay, this is 1, 2, and let this be 3. Forgive my drawing. So from this we can get what? Y of t is equal to 2, and let this be 1. Okay, 2x of t, and how will this be? This will be, the shape won't change. Okay, the shape won't change, it will be the same as this. Suppose this is a proper triangle and time. Okay, the shape won't change, and also the time duration where the peaks and the different positions are, it won't change. The overall shape or the window in which it is occurring, it won't change, because here it is starting at 1, it is starting at 1. It is peaking at 2, it is peaking at 2, and it is ending at 3. This is also ending at 3. So that won't change. Whatever is happening along the time axis, it won't change. What changes though is this one, the amplitude changes. For example, here if it was 0.5, here will be 1. So at every moment of time, the amplitude is doubled. If c was 3, it would have been, instead of 2xt, it would have been 3xt. That's it. That is, for every moment of time, a constant is being multiplied with the existing value. That is amplitude scaling. This is for discrete signals also the same thing happens. Suppose we have something like this, right? We have 1, 2, 3, 4, and 5. So it will be 1, 2, 3, and 2. Okay, if this is let this be x of n, and if this is 2x of n, that is y of n. If this is happening, similarly, so it will be 1, 2, 3, 4, 5, that won't change, but this will be 2, 4, 6 and 4. Only the amplitude changes for the corresponding time. Okay, now let's move forward. The next operation is addition, signal addition. So what is it? From the name itself you may get an idea. Let's call it not x, y of t is equal to x1 of t plus x2 of t. What will be the discrete counterpart? Y of n will be x1 of n plus x2 of n. Okay, suppose we have let's say this as x of x1 of n, x1 of t. Okay, so this is 0, this one, this is 2, and let this be 1. Okay, we are adding it to another signal which looks like this, right? So this is 0, this is 1, this is 2, and this is also 1, x2 of t. So what happens? We have to add this, right? When we are adding this from 0 to 1, what is there? For every point of time, you have from every point of time where the signal exists, either of the signal exists, you have to add, right? So let this be 3. Okay, let this be 3 and 2, 3. Okay, so from 0 to 1, this is 0, only this is there, so it won't change. 0, 1, this will be 1. Okay, at 1, how much is there? At 1, 1 is there plus 1, so it will be 2, right? It will be 2. This is a y of t. Okay, at 2, at t equal to 2, how much is there? 0 plus 1. At t equal to 2, we have 0 plus 1, which is 1. And since this is like a negative slope, and this is just a what do you say, a step function for the time being, just a rectangular function, and is having a constant 1, it will be like that. This much portion is bumped up, this much portion is put on top of this one, right? So let me just redraw it properly. I of t. Okay, this will be like this. 2, this will be, that is this much, this slope will be exactly coming here. Okay, so you can verify in between whichever point you see, this will be added to this constant value. So this much area, it will be added, it will be like this put on top of this one, right? And after this, from 2 to 3, there is no value for this after 2. From 2 to 3, only this much is there, so it will be same. So this is the result of sum of x1 and x2, y equal to x1 of t plus x2 of t. Similarly, you can do for discrete. I am not doing it because it is a trivial solution. It is same as this one. There is no difference to be seen. Okay, that is for every time, every point of time where there are samples. You have to add both the signals, and you have to do that for all values in which either x1 or x2 has a non-zero value. Okay, here from 0 to 1, this has a non-zero, x1 has a non-zero value, but x2 is 0. So you have to find before 0, both of them are having zeros. 0 value, so you don't have to find. Similarly, after 3, both of them are having 0, so you don't have to look at that, right? So that is signal addition. The third one is multiplication. So we have y of t is equal to what? x1 of t into x2 of t. Similarly, y of n is equal to x1 of n into x2 of n, right? This is also similar to addition. For every point where either of the signal has a non-zero value, you have to consider. Okay, so let's consider x1. Okay, let's take our old signal which we had considered, right? 0, 1, 2, let this be 1 into 0, 1, 2, 3, let this be 1, again this is t. Okay, so this will give, what will it give? Right, from 0 to 1, okay, this is having a positive t, something like that, but here it is 0, so 0 into anything is 0, right? 0 y of t, 0 into anything is 0, so 0 to 1 it is 0. From 1 to 2, right, from 1 to 2, this is having a certain value, and from 1 to 2, this is having a constant 1. So 1 into this thing, this will be that thing. Whatever is here will be coming here. If it was some other function, suppose this we can model as some constant into minus t, or some constant plus minus t. Similar, so that will be minus t into something for this duration. If this one also had some minus t or plus t or something, it will have be t into t squared, some parabolic function would have come here. But now this one also, it is just a constant into minus t. Okay, again from 2 to 3, this is having a value, but here it is 0, so it is 0, right? So if you can compare this one and this one, addition and multiplication, what you can say is, in addition, the signal actually gets longer than either if there are non-overlapping areas in time. That is, here from 0 to, only they have a common area only from 1 to 2, right? From 0 to 1 and 2 to 3, only one of them have some values, but when it is added, the resultant signal is from the whole duration, where either of them have a value. But in multiplication, the resultant signal has a value only in areas where it is coinciding, where both of the signals have a value, right? Similarly, you can do the same, like in addition, the same thing happens in discrete domain. In multiplication also, same thing happens in discrete domain. The solution is trivial. Okay, so let's move on to the next one, which is differentiation. Okay, differentiation. So the equation is y of t is equal to d by dt of x of t. So differentiation is for continuous time signal only. The equivalent for discrete time is difference, right? It is called difference. So we won't be dealing with it right now, because we need to learn a little bit more for understanding this one. So difference is x of n minus x of n minus 1. Okay. So unless you learn this term, there is no point in going through this. So let this be. Let this be. We'll set this apart and we'll move on with this one. Okay. So basically differentiation is we are differentiating whatever signal we have and we are finding the result. So suppose we have the signal x of t, right, as this one. Okay. 0 to 1. So what is this? This is t, right? Mathematically you will get that this is t, and it is only up to this much. Okay. So if you are differentiating, what is happening? What is the derivative of t? It is u of t, or it is a constant. Let's say it is a constant only. Okay, it is a constant 1. So for whatever duration the signal was there, the derivative will be actual derivative of the signal and will be present for that particular duration, right? And the next one is, fifth one is integration. Y of t is equal to integral minus infinity to t x of t, sorry, x of tau. You cannot have the same variable here. D tau. Okay, and the discrete equivalent is called as summation. Actually it is the same thing. If you look at it, we are just using the, since this is a continuous time signal, you can integrate, and since this is a discrete signal, you cannot integrate, you have to sum, you have to add up, right? From minus infinity to n summation x of tau, it is the same thing, right? X of tau. So this will be y of n minus 10. Okay, again let's set this apart for now. So I am taking the reverse of the earlier thing. We have a signal like this, 0 1 1 x of t. So we are integrating, means we are adding from this point, right? We are slowly adding from this point and coming like this. Or you can consider this as the integration of the value 1. Okay, so if you integrate it, you will get something like this. Okay, that is integration. So let's go through that operations one by one. First of all, we mentioned that the operations can be done on two variables, that is the independent variable which is t and dependent variable which is the amplitude. So 5 operations. One is amplitude scaling, addition, multiplication, differentiation and integration. So I am stopping this lecture here. In the next lecture we will talk about operations on independent variable which is t. Thank you.